All right, here we go. So I'm starting a video. Okay, we're doing chain rule today. And this lesson is going to be off the chain. This is great. I did. It is on the video. All right. The video's recording me right now, and it's showing how lame I am. All right. So example 1 says 5x squared plus 3x all to the 7th power. Okay, so what the chain rule tells you is you have to take the derivative of the whole deal. It's like taking the wrapper off of the candy. Okay, so that turns into kind of like a power rule situation where you bring the power of 7 down, you multiply it by all the stuff that's inside, and it's to the 7 minus 1, which is the 6th power. Okay, where the chain rule part comes in is we haven't done anything about what's inside the parentheses. So now we have to multiply and take the derivative of the inside of the parentheses. Just you're multiplying this first part by whatever the derivative's inside is. Okay, so the derivative of just the inside, 5x squared, is 10x plus 3. All right, and that's your answer. Okay? So I have this one, y equals 4x to the third minus cosine x, all that under the square root. So all I'm going to do is rewrite this function using some powers to help me out. So I know that this is 4x to the third minus cosine x, all raised to the 1/2 power. And now that I have it written as a power, I can go through and do power rule first and then apply my chain rule second. Okay? So if I take y prime, all right, which remember is the same thing as saying dy dx. All right, those are equivalent. Y prime is equal to, you got 1/2, all of this crap in here. All right. 1/2 minus 1 is to the negative 1/2 power. Okay. So that's taking care of the power rule part of this problem. Now what we have to do is we have to go back and multiply. All right. Multiply by the inside derivative. So what is the derivative of the inside? 12x squared plus sine x. Where'd y'all get plus from? Look at y'all. Calculus rock stars over here. Let's go. Hey, that's off the chain right there. Here we go. All right. So you could leave it like this. Guys, you could simplify this bad boy right here a little bit. If you wanted to get rid of the negative 1/2 power, you could say this is 1 over square root of all that in the bottom. Okay, that's coming from that times your 12x squared plus sine x. And some people put that in the top as well. Okay, and again, I'm not as worried about the simplification part as I am about this. Okay, I want you to be able to apply the power rule and apply the chain rule more than anything. Okay, yeah, the two would have to come down. All right, so example 3. You got y equals 3 over this whole conglomerate of stuff. 11x squared plus 11x to the 4th plus 4x squared minus 9. All that is raised to the 3rd power. So again, I don't want to do anything with quotient rule. I want to try to get this into a power rule scenario so I can use power rule and then use the chain rule. All right. So I'm going to take this whole thing in the bottom and move it up to the top. I'm going to get rid of the fraction.
But doing quotient rule would not, it would use the right answer, right?
Okay. It could. It's going to be it's going to take forever. Okay, so what I recommend is doing this. You bring all that up to the top. Minus 9. But now it's to the negative third power.
Oh, so you don't change stuff on the inside?
Nope, don't change the stuff on the inside. You only change the exponent. Okay, so that is now your new function. Y equals that.
I probably wouldn't never get.
Okay? So now all you're going to do to get y prime is you're going to apply your rule. So negative 3 times your 3 in the front. Negative 9, you got all that stuff in there. Minus 9 to the negative fourth power because you have to subtract 1 from negative 3. Okay, and now you multiply by the derivative of the inside. 44x cubed plus 8x. Bingo. Okay, again, if you wanted to simplify, we could take all this and put it in the bottom with a positive exponent. Not necessary for the example. Okay, so that's okay right there. Chain rule. All right, let's look at example 4. Y equals cosine of 5x. Now, the same rule applies with trig stuff. So we've looked at mainly like some polynomial type things. All right, your trig things still apply. So sometimes you can have something besides 1x in that parentheses. Most of the time we just write it as cosine x. But really that's like cosine of 1x. Okay? So your chain rule for these trig problems is going to be kind of the same way. I'm going to take the derivative of the whole thing. All right? Derivative of cosine is negative sine of whatever that whole deal is. 5x. Okay? And then just multiply by the derivative of the inside. Times 5. Okay? So I am going to simplify this because that's just negative 5 sine of 5x. So it's just taking the derivative of the whole thing and then the derivative of the inside. Here we go, example 5. Y equals 8 secant of e to the x. Okay? So, now we got to go look at, all right, what's the derivative of just secant? Okay? So the derivative of secant x is secant x tan x. So here y prime is 8. You have secant, whatever that x is, it's e to the x, tan x. Okay? That's your derivative of the secant.
Wait a minute. Why gotta be? Why is it being there for?
Now we have to multiply by the derivative of the inside. Times e to the x.
You said what is secant x? So x is.
That's it.
Oh, because it tells us in the problem. Yeah.
Mm-hmm. All right, look at example 6. Let's see how we do with some of these. Okay, f of x is 1/2. You have tan. Instead of tan of x, it's tan ln x.
Correct.
So the ln x is kind of like our quote-unquote x for tangent x. Okay? So, let's take the derivative of the whole thing. So f prime of x, that constant we just pull out front, right, times, what's the derivative of just tan x?
Secant squared. Yeah, secant squared.
Yep, so that's over here in my thought bubble that I'm going to memorize for my quiz tomorrow. All right, or just commit to memory. All right, that's secant squared. So now in place of x, we have ln x. So I have the derivative of tan is secant squared, but instead of x, it's ln x. Okay, and then I have to multiply by the derivative of the inside.
1 over x.
Times 1 over x. Look at y'all.
I finally understand, so I'm so
Okay.
excited.
Look at that. All right. Okay, so skip 7. We're going to go to 8 on the back. Derivatives 34. Y equals 9 e to the sine x. Okay? So, I'm over here thinking in my cloud bubble. All right? E to the, let's say e to the u. What's the derivative of e to the u? Okay, the derivative of e to the u is e to the u, right? Du dx. Okay? So, right now we have u is sine of x, right? So if I'm looking at y prime, 9 e to the same deal, all that junk, times the derivative of, what have we not taken the derivative of yet?
That 9. I mean, wait till 9.
No, we took 9e to the x. We hadn't taken the derivative of sine yet, have we? So we hadn't taken the derivative of u. So I need to know what this du dx is. So what's the derivative of sine? Cosine x.
What is the x for? Why would you bring it in?
Okay, here's 9. All right. Y e to the negative 5. 5. Negative 5 e to the x to the 7th. Okay. So you're treating the x to the 7th as what e is raised to. Right? So y prime for this is just negative 5 e x to the 7th times the derivative of that stuff that we circled. The derivative of x to the 7th. So what is the derivative of x to the 7th?
7x to the 6th.
Okay. Now you can simplify that a little bit. 7 times 5 is negative 35. All right. E x to the 7th, x to the 6th.
Why the e not included when you had did the?
All right. Number 12. Y is equal to ln x squared plus 5. Okay. So use your derivative rule. It's number 5 on our board up there. All right. So this is 1 over all that junk. Okay. Here's my thought bubble. Ln of x, the derivative for that is 1 over that x. Okay? So in our case, there's more than just an x in there. So we got to put all that stuff in the bottom. I had a teacher in college, he called it the blob of stuff. Right? He called it like a blob. All right? He'd say 1 over the blob. Whatever works. I don't know. Okay, now we got to apply the chain rule part. So I got to take the derivative of the inside. What's the derivative of the inside? 2x. So you could, leave like that. You could say 2x over all that. That's it. Okay, that's your derivative on 12. Okay, 13. 13 kind of looks weird. Just because of notation. You guys probably haven't ever seen this notation besides when I wrote it on the board the other day. All right. Cosine squared of x. Do you see what your paper says? It says rewrite it as y equals cosine of x squared. Okay. When you write it like that, that makes it a whole lot simpler because I can go power rule and then multiply by whatever the derivative of the inside is. So I can kind of keep my rules consistent when I do this. So if I were to do that, y prime is bring the 2 times cosine x to the first. Do I have to write to the first? No. Times what's the derivative of the inside? Negative sine x. Okay. So this is just negative 2 cosine x sine x. You can put those in. You can put the x in parentheses if you want. Doesn't matter. Okay.